All right, grade 8. Calculating area as a sweep. I'm going to go through one example with you first, and then I'll go through the practice set with you, and hopefully by the time we're done that, it'll make sense. Okay, calculating area as a sweep is just a different way of calculating area. There are more ways that you can figure out how to do area, but this is one that we need to focus on for this lesson, as it'll have more practical lessons later on. So normally when you use a broom, for example, if you have a rectangular area and you have your broom, oh boy, if you have your broom going and it pushes that way, all right, you have your brush on the end of the broom. I don't know how a broom has a handle on it, but that's easy to figure out the area. But what if you had a broom, for example, that was over here, and you had the one end of the broom here, and you were sweeping an arc that way. So this one's making zero travel on this end, but this end here is traveling. Right? So in order to find that distance, the average distance traveled, we will take this number here, and we will take this number here, and so we'll add x plus 0 and divide it by 2, and that will give you the average. That's the key concept that they're looking at training you on this time. So if we have one of these circles, for example, and we have a broom there going across that circle, if this were turning all the way around, we have a radius of 5. It's asking us, for example, how far does point A move around in one full turn, right? And we're going to express this as pi. So if we look at point A and we have point C over here, how far does it go in one turn? Well, we know that to figure out what it's gone in one turn, we go pi times diameter, which would equal 10 pi. So we know that that's pretty easy. How about point C? Is that going to move? Point C is going to move 0. So normally we divide that by 2, and that will give us a total travel of 5 pi. So how would you find that average travel and the distance moved? So you would multiply it, of course, by 5, which is this distance that it's pushing every time, and our rate of travel. So 5 pi times 5, and we get 25 pi squared. So we know that this science does work behind this, and so it will work with smaller arcs as well, because to find the area of a circle is pi r squared, which would be 25 pi, which would be 25 pi. So that all works. So I'll go through, and that was a very quick demonstration. You can read more about this in the examples that they give, but let's walk through the practice set questions. Imagine a broom steadily narrowing from 12 inches to 0 inches as it sweeps 10 inches to form a triangle. Okay, so here we have, oops, I'll try to draw it a little bit neater here. We have our triangle, okay, and we got on the one side 12 inches, and then the other side, our length here, maybe I have to look at this triangle a little bit nicer, there, and it comes up here, something like that. That's probably a nicer way of drawing it. We got 12 here, and we have 10 over here. That's how the book is showing it. Okay, describe how to find the area of the triangle. Right, so we start at a length of 12 inches, and we go to a length of 0 inches, right? So we divide that by 2, and of course we get 6. Now we get a rate of speed of 6 inches times 10. We know that we get 60 inches squared. So the average length of the broom times the distance that it went. So the average length of the broom will be 6 inches times the distance it went, which is 10. That'll figure that out. The next one has a picture of, ooh, I didn't do that right. Let's try that again. A cylinder, and it says our cylinder is 5 centimeters with a diameter of 10. So it says segment AB is 5 centimeters long. So this is AB. And the diameter of the cylinder is 10 centimeters long. Describe how to calculate the lateral surface area of the cylinder. And find the lateral surface area in terms of pi. Well, this one's simpler because we know how to find, we need to find out what this circular area is, and that would be pi d. So we know we have 10 pi, and then we have our height to figure out for that rectangular piece now that we have. So we know that this side is 10 pi, we know that our height is 5. So 10 pi times 5 gets us 50 pi centimeters squared. And that was a quick how-to on this lesson. So hopefully that makes sense. If you have any questions, I am available on Meet. Make sure that you do the even numbers